Welcome everyone. I am Ujjwal Pal. Today we will solve a LeetCode problem step by step. The problem number is 1110, which is delete nodes and return forest. The problem statement says, given the root of a binary tree, each node in the tree has a distinct value. That means every value in each node will be distinct. There won't be any same number in two different nodes. After deleting all nodes with a value in to delete, we are left with a forest, a disjoint union of trees. That is, there will be given a integer array, that is to delete, and we have to delete that nodes which have the value uh, present in to delete. And after deleting, we will have a forest, which is a disjoint union of trees. Return the roots of the tree in the remaining forest. You may return the result in any order. And after deleting the nodes which have the values present in to delete, we will have some nodes, may or may not be, but we will have some nodes which do not present in to delete, and we have to uh, add them add their root in a vector, and we have to return it. So our task is this. So I will explain you the algorithm first, then I will move into the C++ code. So see, there is a condition that if the node value is present in to delete, we have to delete that node. So between parent and children, how many possibilities are there? There is four possibilities, which is the parent is present in to delete array and the child is also present. One. Second will be the parent is present but the child is not present. Third will be the child is present but the parent is not present. The fourth will be both are not present in to delete. So if see that if the parent is not present in to delete and the child is present, then we have to uh, delete that side of the parent. Like if the child is left child, then we have to put a null pointer to the left, and if it is right child, then we have to add the right pointer to the right. That is the simple. And the second case, if the parent is present in to delete and the child is not present, that means the child is a new head of another disjoint tree. So we have to add that node to the our answer array, because that will be a new head of a tree. So this is the main two condition, and the other twos are both are present and both are not present. In those cases, we do not have to do anything, because if the parent is present, that will already be uh, added in the vector, and if the child is also present, then we do not need to change anything. And also in the case where both are present in delete to delete, then we do not add the parent and we also do not add the child, so we do not have to think change anything, like left child or right child. We have to add null pointer this time, this kind of stuff. We do not need to do anything, just we need to focus on two cases, which is parent present, child not present, and child present, parent not present. These are the two cases. So this will be the simple uh, algorithm, and if the constants are, there will be uh, maximum thousand of nodes, and each value will be 1 to n, which is 1 to thousand maybe. And to delete, length of the to delete array will be less equal to 1000. Like you may delete some of the nodes or possibly zero, and all the nodes maximum. So these are the constants. Let's move on to the C++ code. We will understand the algorithm after seeing the algorithm. So first, what we will do, if it is as it is the array, we can't like uh, check if one is present in that. So we have to traverse the whole array to check if one is present in that array. So what we will do, first we will create a unordered set with all the values present in to delete, so that we can easily check if one is present in to delete set or not. So first we will make a set dot set int for we will add all the values of to delete array into the set dot insert it. That's it. Now we have a set with all the elements, all the distinct elements of to delete arrays. So we can now easily check if 3 is present or not in we go up one time, or you can say the constant time. So this is the first part, and now we will need to make a answer array which we will return after the function call answer. Let's make a function. First I am making the call, then I will make the function body. First we will pass the root and obviously the set. And if you think like that, if I am currently we are standing at any node, like for example 2, then we some like if the parent is present in not present in 2 delete, but 2 is present, then we need to delete the left child of the parent. So we need to keep track of the parent of the current node. So what we will do, we just pass like null pointer here, which is the parent of root node, and the answer obviously. This will keep track of the parent because the current node parent will keep track. We need to keep track because there is a case we need to check, and we will return the answer. Now we'll make the function. It will be void return type. uh, the parameters are first the root and then copy pasting it, and second one is the set. As the set is will not change in the function, so we can take the reference of the set. It will decrease the space. So that's why I am keeping the reference. And third one is the parent, so we can just take this and write parent. And the last one is the answer. The answer is also we will can take the reference. So we need to have the reference because it is present in this function del nodes. So yeah, if we change anything in the helper function, if we do not add the reference, then every time the new instance of answer will be created, and if any changes happen in the helper function, it will not be reflected in the del nodes function. But we do not need that, so we will always use the reference so that every change in the helper function will reflect in the main function, which is del nodes. So this will be the parameters of the helper function. So first we will check if the root is not present, we just return. Now, first case and second case. First case, what you I already told you the two cases which we need to focus on, that is parent present in delete node and child is not present, and child present and parent not present. So anything you do first I'm writing if like parent is present on to delete and child is not present. That means the current child could be the root of the new tree. So we will have to add the in answer array. So I am keeping that in first case. So first we will check as for the first node or the root node doesn't have any parent. So first we have to check if not parent. That means we directly like there is no parent of the current node. So we do not check anything. Or if the parent is present, then we have to check the parent is present in that delete node. So st.find the parent value if it is present or not. So if it is present, it not equal to st.end. It means that the parent value is present in the set. That means we have to delete the parent. So if we delete the parent, and we also have to check and the current node is not present in to delete. So what we will do, I'm just copy pasting. If the root value is not equal to end means we have not find any values in the set. So the current value is not present in the set. So that means we do not need to delete the current parent. So it will be the new head. So what we will do, we just answer dot use the root, not root value because we need to have the root node, the tree node start. So we do not have to write the root value, just directly the root. This will be the first case, and second case where child is not present, child is present, like child have we have to delete the child and parent is not present in to delete. So parent will be there, but child is not there. So the second case will be look like this. If uh, child is present, which means root value is not equal to end, which means child is present in to delete, and the parent is not present. So parent is not present. So first we have to see if the parent is present, because for the root node there will be no parent. So just checking the parent is present and the value of parent is equal to it. Equal to it means it is not present in the set. So what we will do, we have to delete the current node or the child of the parent node. So we do not know if it is left child or right child. So we just check if the parent left is equal to root. Means the root node is the child left child of the parent or not. If it is, then parent left equal to set it to null pointer, and else parent, if it is not right left child, then it is the right child. So just set parent right equal to null ptr. That means the we set the parents left or right child, so null pointer. That means the current root node will not be referenced by the parent nodes left or right child, will not be referenced. So we finish the two cases, and we do not need to think about the other two cases which are both are present and both are not present. I already told you that we do not need to do anything. So now we have finished the two cases. Now we have to just call the function for the left child and the right child also. So root left and h2 will be set to the same. The parent will be the current child, because we are going to current node's child. So for them, the parent will be the current node. So root and answer will be the same. And just publishing left to change it to right and everything will be okay. So let's see if it is works or not. The test is accepted. Let's submit it. So you can see it is accepted. So now I will explain you the time and space complexity. So if you can see that we are traversing the to delete one time the whole array, and to delete is maximum could be in worst case it could be the same as the number of nodes. That means it will take big of n time, and this function is also takes the big of n time because it will traverse the whole array, whole not array like whole tree one time. So it will also take big of n time. So the overall time complexity will be big of n plus big of n plus n, or you can say big of n. But big of 2 into n is also you can consider as big of n. So the overall time complexity will be big of n. And what will be the space complexity? We are using a set which will keep track all the nodes of delete. So in worst case, it could be like the size of the not the size, the number of nodes in present in the tree. It could hold the all the values. So it will be also big of n. So the overall space complexity will also be big of n. So time and space complexity both are big of n. That's it for today. See you in the next video.